When I'm looking at problems involving consecutive integers, I begin all of the problems in a very similar way. I read through my problem and determine how many I have. In this case, I have a set of 3 consecutive integers. So I'm going to define some variables. I let x equal my first number. And since there's a relationship between these numbers, they're consecutive integers. In other words, they all come in a row. For example, something like 3, 4, and 5 would be a set of consecutive integers. If I call the first one x, in order to get to my second integer, all I have to do is add on 1. So x plus 1 is my second number. And then in order to get to the next one, I would just add on another 1 to the x plus 1. So x plus 2 is my third number. So that still works in my example up here. 3, 4, and 5, x plus 1, x plus 2. Now that I have all of these defined, I can use them whenever I begin to translate the problem into an equation. The way I know it's an equation is because as I read through, I find this word is, which 99% of the time tells me that's where my equal sign goes. So everything to the left of it, I'm going to translate and put on the left in my problem. So I want 3 times the largest integer. In this case, the largest integer is going to be my third one right here. So 3 times that would be 3, and in parentheses, x plus 2, because I'm taking 3 times the whole quantity. And then it says is or equals 9 more than means that I'm going to put a plus 9 at the end of whatever I have. I continue on, and then it says the sum of the other 2 integers. Well, the other 2 integers in this case would be x and x plus 1. If I find their sum, which is addition, I combine like terms. So I get 2 x's and then just plus 1. Don't forget there was the 9 more than. So I put the 9 at the end of that side of my equation. So I've translated all of this information into an equation that now all I have to do is solve by simplifying both sides first, distributing on the left to get 3x plus 6. On the right, I'm combining like terms, and I have 2x plus 10. Get the variables to the same side. In this case, it's smartest to subtract 2x, because that will keep things positive. Gets rid of the variables there, and leaves me with x plus 6 equals 10. One more step till I find x. Subtract 6. I get x equals 4. Now I need to go through and analyze what this means, because it says find the set of 3 integers. There should be 3 things in my answer. So I look back over here where I defined things in the first place. And I said x equals the first number. So my first number apparently is 4, because he's x. Now plug him in. I take x plus 1, so I get 5 for my second integer. And then I get x plus 2, so 4 plus 2 gives me 6 for my third integer. So my final answer, I'd like to write it out nicely, the set of integers is 4, 5, and 6. That's the only set of numbers that's going to satisfy the conditions in the problem that I was given.